Welcome, Mourad.
Hello, hello everyone.
You are Chief Software Officer since 4 years at PASQAL. Can you just remind us, what is PASQAL? What's you doing?
Yeah, so PASQAL is a company of 350 people now, and we build quantum computers. So the core business is to build these new processors and to develop great applications on them.
Okay. What is actually the integration of quantum computing in the HPC context?
Yeah, so HPC is a pretty big thing, and especially in the finance sector and in financial modeling, there are like lots of customers of HPC. And in the past years, we've seen a big increase of HPC needs, especially with Gen AI. The HPC ecosystem is undergoing big changes to try to include new technologies, and quantum is one of them. So quantum and HPC are not two opposing modalities. They're actually complementary. So you can think of QPUs, quantum processing units, as accelerators for some types of computations like GPU were some years ago. So the main idea is to improve and accelerate some types of computations. And the main areas we focus on are usually optimization problems, quantum machine learning, and simulation.
Okay, and what are the efforts of PASQAL in this domain?
So at PASQAL, we build both hardware and software. We believe it's important to have not only scientific R&D, but also to industrialize that science into products. And in addition to that, we also need applications, because processors alone are not going to bring value. It's the end application that brings value. So we can see that with GPUs. I mean, it's all the Gen AI models that run on these GPUs that create the value. So at PASQAL, we do both hardware and software. And of course, our goal is to put those processors in the hand of people, of domain experts, so that they can build great applications.
Okay, there is a European context about HPC. What's happened actually in this part?
Yeah, so Europe is a good place for quantum today. There are lots of initiatives in trying to put quantum computers in HPC centers, in national computing centers. For example, at PASQAL, we have shipped our first device to a computing center in France, to CEA. It's actually being installed. We have a second device that will be in Germany next year. And Europe is really trying to strengthen its position to that. So yeah, at PASQAL, we also try to collaborate with other actors. We have a partnership with IBM to try to uniformize the way we integrate quantum in HPC centers. So we call that quantum-centric HPC. And the idea is to make it easier for HPC centers and end users to use and integrate quantum.
Okay. One question that I have every week is, what is the difference about the consumption of HPC and quantum computers? Is it better to use quantum computer?
Yeah, so energy consumption is a big thing in HPC. So standard supercomputers consume in the order of 1 to 10 megawatts. Our processors today consume a few kilowatts. So this is really a big difference. You could plug PASQAL computers in your kitchen on the plug, and it consumes as much as, I think, 2 hair dryers or something like that. So this is a big difference. In addition to the increase in performance, we also target a much better use of energy and of power.
Okay. What are the use cases? What subject we can do with quantum computers? I think in finance it's really interesting because you have optimization, combinatory optimization, optimization risk, or portfolio. Can you explain a bit more about that?
Yeah, I can give some examples. So usually any industry that uses HPC is a good candidate for quantum. The main areas that are relevant for finance are combinatorial optimization and quantum machine learning. So as an example, we did a project with Crédit Agricole 2 years ago on risk management. So the goal of the pilot project was to anticipate risk credit score downgrade and to assess the ability of given entities to pay back their loans. So this is one example which we published and communicated on. You can find more information online. We also have other use cases under development. A few examples are portfolio optimization, optimal placement of assets using combinatorial optimization and quantum graph optimization. We also have financial arbitrage, again using graph optimization. So the goal here is to model the assets as a weighted graph and to look for Hamiltonian cycles or shortcut paths to make a gain from that. We also use quantum machine learning for fraud detection to detect anomalies in transactions using pattern recognition, for example, or to do network analysis to detect suspicious entities and suspicious clusters. And yeah, there are quite a few. And finally, like in every industry, there are also interesting use cases in logistics, planning, and scheduling that are could be relevant for finance too.
Okay, I think last year we had a panel about Crédit Agricole use cases, and I think it was really interesting because they use less data for the same use case that they use in HPC, and you have an advantage to use less data but also less energy, and it was you can see the replay, I think, of the last year for more details.
Yeah, yes, exactly. I mean, just on that, we developed an optimization model that found the same results with the same precision, but with, I think it was 96% less data. So we had much more expressivity, and that was thanks to the, let's say, quantum algorithm design.
Mm-hmm. Where stands PASQAL today about this and the partnerships that you can have?
So at PASQAL today, we are on the market already. So we have a 100-qubit device that is available through the cloud. In the lab, we also pursue more performance. So we already had some publications with a 1,000-qubit device, which is a pretty big achievement in the market. We also develop partnerships, either with end users or with integrators and consulting companies to try to tackle the market.
And what are your hopes for the future?
My hopes, I think, I wouldn't say it's a hope, but I think that there will be a quantum computer in every HPC centers in 5 to 10 years from now. My hope is that it will be a PASQAL computer.
Obviously. Another thematic, and we are at AI for Finance, it's what are the synergies with quantum computing and AI?
So AI is typically one interesting use case because it uses a lot of resources. So we've seen in the past year, I think it was in 23, there was plus 40% of NVIDIA GPUs sold, which is, they were already selling a lot, so it's a very big number. So it's very interesting for us to understand if there are specific points in AI where we can help with quantum. So far, we've been studying graph machine learning approaches for chemistry and for finance. So the idea is to take standard HPC workflows, standard AI workflows, and to enhance a few steps with quantum. So the goal is not, again, to put quantum in opposition to classical, but rather to build hybrid workflows. And we think this will be the path to get AI to the next stage.
Okay. Another question, it's about how to collaborate with you. For example, if I am an industrial, how can I work with you?
So PASQAL is a full-stack company. We build the hardware, we build the middleware, and we build the software and the applications too. But we are experts in quantum. In order to build applications that have impact, it's important to also have domain expertise. And our goal is not to have that alone. The goal is to collaborate with clients, with customers, into these collaborative R&D projects where we bring our quantum expertise. Clients can bring their domain expertise, and we together identify a use case that is relevant for quantum and develop a solution to it. So this is what we did with Crédit Agricole. This is what we did with BMW, LG, Johnson & Johnson in other industries. And we're really open to pursuing this model. We think this is, in the short term, the best way for people, for big corporates to engage with quantum.
And do you have collaboration also with other startups, maybe in software or in other fields?
Yes, yeah, of course. We also collaborate with, we also have partners, and we collaborate with other startups in the quantum ecosystem. So we work with Kipu, for example, and our goal is to together also develop use cases, and again, to tackle new verticals, new industries in the market.
Last question. Maybe about cloud computing. What is the place of cloud for the quantum computing? Is it important, or do you think it's better to buy your machine?
So machines are still very expensive and pretty hard to maintain. So we believe it's very important. It's crucial to have cloud access to start with. This is how people can more easily, this makes the technology more accessible, and this helps people really get their hands on the devices and start building things. So for us, today it's very important to have this collaboration efforts between providers, research institutes, and industrial players to understand the impact and build applications that matter. So this is why at PASQAL we have this approach where we put devices on the cloud, but we also try to open source as much as possible our software stack so that other people, hopefully people in this room, can take that and build applications on their side. So our goal, I mean, right now the technology is still being developed, but our goal is to build abstraction layers and have tools, functional primitives that speak to domain experts instead of quantum experts. And so we believe that this open sourcing strategy plus the accessibility of cloud access is what can make a difference in the way the technology will grow.
We have a bit more time. The last question. What do the French government actually to help the ecosystem? Do you see things interesting to follow? If you are industrial. Yeah.
Yes, exactly. So France just launched a program to put quantum computers on the cloud and to give access to multiple modalities, multiple types of technologies. That's called the AMI Aquila. Following this, there will probably be the potential for big corporates to create projects and get subsidies from the government. So France, compared to other countries, is investing a lot, and especially for corporates, I think this is a great opportunity to be able to put a foot in the industry and maybe be ahead of other competitors. So our goal is that in the short term we can build applications that are on par with classical methods, and to demonstrate that the scaling of these applications will be much better than what you can get with standard HPC.
Thank you very much, Mourad, for this intervention. If you want to have more information about PASQAL, I think you have a booth.
Yes, exactly. Feel free to stop by the booth. We'll answer any of your questions.
Thank you very much for following this panel. Bye.
Thank you, Fanny.